Hello, my students. Today we are dealing with modeling. Let's get started. Problem 1. A fruit vendor records that on day 1 of a market she sells 25 kilograms of apples. On day 5 she sells 45 kilograms. And in A we have to create a linear model. So firstly, we can recall how does it look in standard form. So it is y equals mx plus c, and it is the same as f. X equals mx plus c. However, our function is a versus d, so it will look like md plus c because our x is d, and d is the day number and a is the amount of apples sold. And 1 and 5 are d because these are day number, and 25 kilograms and 45 kilograms are A, so the amount of apples sold. And from this we can simply find our gradient, and this and its formula is y2 minus y1 over x2 minus x1. And this formula is in your booklet, so don't worry, you don't need to remember it. You will have it during your final exams. And yeah, our y2 is like a2, and y1 is like a1, and x's are these, so d2 minus d1, because you can see that our d is like x and our a is like y. And we can substitute our values, and we have 45 because this is our second amount of apples minus our first amount of apples over day 5 minus 1, and it equals 5. So for now our function looks like this, and we have to calculate c, so we can calculate it simply by substituting day 1 or day 5 with its apples sold. So we can take the first day, we have a, so 25 equals 5 times 1 because we have first day plus c, so it is 25 minus 5 because we have to subtract 5 from 25, and it equals c, so c is 20. So our final function is ad equals 5d plus 20. And in point B, we have to use our model to predict how many kilograms she will sell on day 7. So our day number is 7, so we simply substitute 7 into d plus 20, and it's 35 plus 20, and it is 55 kilograms. And in point C, we have to identify one assumption made in our model. And from our model, we can see that the number of the amount of apples sold increases every day by 5, because on our day 1 we have 25 kilograms sold. We have 25 apples sold. On the second day, we can see that on the second day we have 5 times 2 plus 20, so 30 kilograms. On day 3 we have 5 times 3 plus 20, so 33, and so on. So we can write something like this. Sales increase steadily by 5 kilograms per day, and there are no external factors. Problem 2, it's a little bit more complicated because we have to write a piecewise linear functions. C for the total cost C depending on the distance x in kilometers. And we have some important information that a base fare of $4, so it's a fixed cost. We have $1.5 per kilometer for the first 10 kilometers and $1 per kilometer for each additional kilometer. So for sure, firstly, we will write two functions for the total cost. The first will be 4 because it's a fixed cost, so we have to pay it anyway, plus 1.5x because x is our distance and we pay 1.5 per kilometer for the first kilometers. So our domain is from 0 to 10 kilometers. And now we have to make another function when we have additional kilometers, so more than 10 kilometers. So we, of course, we know that our x will be greater than 10 for our second function, and C, our total cost function, will be for sure 4 because it is a fixed cost, and plus 1.5 because it's our cost for the first 10 kilometers. And if we have more than 10 kilometers, of course, we traveled this 10 kilometers. So we have 10. We substitute it like in here, but we also need to include $1 per additional kilometer over 10 kilometers. So plus 1, and we cannot forget that we have to, in bracket, write x minus 10 because we cannot simply put here x because our x is distance in kilometers. So if we put 1 kilometer, it's not for the second function because our second function is over 10 kilometers. So our x is greater than 10. This is what we wrote in our domain. X is greater than 10. So as you can see, if we have 1 kilometer, we cannot substitute it in here because our bracket will be negative. It will be 1 minus 10, so minus 9. So we have to remember that when we have a piecewise function, we have to also remember about subtracting our number from the let's say first function. So you can see that this 10 is our first 10 kilometers that are connected to our first function. And now we can write our piecewise function. And if we simplify this equation, we will have 9 plus x. And in point B, we have to graph the function. So the easiest way is to graph it on your GDC and then write it on a paper. So this is our piecewise function. Here is the point of king because our domain for the first function ends at 10, and for the second function it starts at 10 opens. And in C we have to use our model to find the cost of 15 kilometers ride, so we have to decide which function we will use, and of course 15 kilometers is greater than 10, so we will use the second one, and it will be 9 plus 15, so it is $24. Now problem 3. A student saves money by putting part-time job income into accounts, account A and account B, with different annual interest rate, and at the end of the year she earned $112 in interest. She had $2,800 total saved. And in A, let x be the amount in account A and y the amount in account B. Write a system of equations. So we have two unknowns, x and y. So this means that we will have two equations. And very important information is also this, and this. Because firstly, we have $2,800 total saved, and our x is the amount in account A and y is the amount in account B. So our two amounts in two accounts equal our total amount saved, so 2,800. So this is our first equation, and the second equation will be with $112 in interest, because this is our interest. And in account A we have 0.03x, because this is our annual interest, and this is our amount, and the same in the second account, but times y, and it equals our interest. And these are our equations. In point B, we have to solve our system of equations to find how much was in each account. So we can simply find our x and y by typing it into our GDC into simultaneous. If you typed it correctly, our answers are the same, so $1,400. And if you are not sure, you can substitute it into our system of equations and see that they are correct. And in C, we have to state one limitation of the model. So as you can see, our account A and account B, they earn a constant annual interest, but in real life banks can change them, so we assume that they are constant over the year and years, but in real life it's not like this. So this is our one limitation of our model, and that's all for today. Thank you so much for watching. Please leave thumbs up and subscribe to my channel, and if you have any questions, feel free to reach me out in comments or via my mail. See ya!